Sorry. Scratch this sentence out. Sorry. Sorry. All right, year 12s, listening. So, um, I found teaching this topic last year. This was a moment where people had a bit of trouble. So I'll try to explain it as best as I can, but it takes a bit of time. So give yourself that. So here's what's happening. I'm always going to start with $5,000. Okay, you'll have more than $5,000 in due time. Don't worry. Okay, but let's suppose, for example, that we invest this in a compound interest investment, and the interest is said to be compounded yearly. So we've just done an example like this, so I won't go through all the details. We've got that. Okay? Now, here's the thing. In the real world, when banks pay you interest, they don't calculate the compounding part every year. They actually do it in shorter periods than that. So they might compound every month, or every week, or every day. Because of that, that actually makes our calculations a little bit more complicated. But if you're the person with the money, that's good for you. Because if we compound more often, we get more money. So I want to show you how this works. So the first thing I want to do with you is to say, what happens if we compound it monthly? Correct. So did you study any of this in year 10 maths? Sub-annual compound interest? Okay, so that's fine. Yes.
All I remember is proving Mr. Higgins wrong. That's all I remember is year 10 maths. I remember being kicked out. You were quite a miscreant. I just remember like telling Mr. Higgins he's wrong about statistics. And then he got mad.
Okay, so year 12s, can I get you to listen to this part, please? So here's what's happening. Here, I've set up a recurrence relation after n years. But now what's going to happen is I'm going to set up a recurrence relation on a monthly basis. So what's going to happen is I'm not going to get 6% interest per month. That would be huge. What's going to happen is I'm going to get 6% divided by 12 interest per month. So why am I dividing by 12? 12 months in a year. So what's going to happen is I'm going to split that 6% interest into each month. So instead of doing 6% at the end of the year, I'm going to do 6% divided by 12, and I'm going to do that 12 times. Okay? So this time, my value for R isn't going to be 1.06. This time, I need to use 1 plus 6 divided by 12 divided by 100. I've divided by 12 because I'm doing it every month. All right, so I'll change the color for the important bits. So 6 divided by 12% interest per month. So can you just check that that's correct? 6 divided by 12 is, yeah? Yeah, okay. Now, let's watch what happens if we do this for 1 year. I've set up my recurrence relation, V naught equals 5,000, Vn plus 1 equals 1.005 Vn, but please note that n is now representing months. So I'm interested now in how much money I will have at the end of 1 year. So Tim, say that again. Why do I need to go 12? Very good. So in the first equation here, I've calculated how much money there is at the end of 1 year. So I use n equals 1, but that was years. In this new recurrence relation, I need to use months. So now I'll calculate V12. And that's why it was so important to go over that formula for a geometric sequence and the rule for that. Okay, so I was going to make a joke. I don't know if you'll get it. Which one's better? Which one do you want in your account? You sure, Tom?
Second one.
This is your money.
$8.39.
Okay.
I'd be happy with you.
So
if you're going to give me $5,000, I'm not going to complain either way.
okay, so it doesn't matter how much money you put in. The more often you compound your interest, the better. So always try to get a daily compounding interest product if you can when you sign up with a bank. Now, I'm going to do one more example. This time we're going to do it daily. Daily. So, year 12s. We're going to compound every day now. So I'm expecting it to be better because I'm compounding the interest more often. And because it's compound interest, I know that I need to use a geometric sequence. So I'm going to need a common ratio, capital R. The question is, what value of R should I use here? Because before, I would have used 1.06 for yearly. When we went to monthly, we divided the 6 by 12.
You should divide it by 365.
Nice. Yeah, so the convention that we use in finance is we assume 365 days in a year. So I'm going to define R equals 6 divided by 365 divided by 100. Yes, this is just the way they calculate it. So it makes it simpler. So don't worry about leap years. Okay? All right, so have you guys got that? Tom, do you understand why we are divided by 365? Okay, and Harry, why are we using 6 in capital R? Okay, so you see this value for R here?
Oh, 6%.
That's it. That's why we're using the number 6 there. Okay, so I'm interested in how much money after 1 year.
I'm gonna try that one again.
Does someone want to calculate?
I came up with 1.000164.
That?
Yes.
Thank you.
Is it better because it's one now?
It's getting smaller, but you're doing it more times. So that's right. Okay, we're nearly there. So that's the recurrence relation once you substitute 6 and 365 into capital R. Now my next question is, I want the amount after 1 year. So what value of n should I use here? 365, because I didn't say this explicitly, but here n is representing days, not years or months. Okay, so to get the amount after 1 year, I need to find V365. And if you do that, let's see whether you can get it before me. Cool. I'll just check that quickly. There you go. Okay, so we got about another 80 cents. It doesn't sound like much, right? So
Where are they giving you 5,000?
these are your options. Option number 1, 5,300. Option number 2, 5,308. Option number 3, 5,309. If you're a business owner and this is billions of dollars, just that
Looks a lot better.
that becomes millions of dollars when you have lots of money. Just a small percentage. Okay, so the takeaway here is, if you can compound more often and you're the one making the money, you should do it.
What would be an average interest rate?
An average interest rate?
Mm-hmm.
So,
What give you what?
okay.
Realistically, what you do?
All right, so I'll tell you what I get. So I have an ING account, and they give me 5% interest on money up to $100,000. I don't have that much money, but they give you that amount of interest up until that amount.
Oh, sir.
I'll show you the legal stuff.
Is that compounded or something?
Compound, and it's
over 100 grand, just the regular.
then you have to invest it somewhere else. They won't give you any more interest. Yeah.
So you could just open a heap of accounts like that.
No, you'd have to open you have to open something called a term deposit with a lower interest rate, and you'd be locked in for longer. Okay.
You can't just like interest.
Yeah.
It does money glitch.
All right. So I'm going to give you a chance now to get started on exercise 7F. Towards the end of the period, I'll cover the last part, effective interest rates. Okay? Please have your holiday homework ready for me to take a look at as I come around.
Tim, can I just question what was the point of that?
I wanted to see if I